Okay, hi everyone, and welcome to the last day of our training provided by Middlesex University. Today we're going to start with data analytics and visualization, and we will continue in later on with the impact of machine learning in the security area, network security as well. And it gives me a great pleasure to have Ariadni this morning. She's gone through a career change in the past few years. She had 16 years of experience as a senior IT analyst and developer, also in industry. So her work was in data warehousing. She's an expert with databases, anything from DBMS and SQL down to Oracle servers and management of data servers. Her work has, she's also from Greece, but her work was not limited to blue chip companies in Greece, but also she has worked with Intersoft International in Belgium for 5 years. So she has experienced working for projects as clients, with clients like the Commission and multinational projects. So with that in mind, you can always discuss during the 3 hours her experiences of the sector, any kind of concerns that you may have for your students, especially when they work for large organizations. Ariadni then moved to the UK. She has worked also with a small company, so she has experience of the different environment that you can have when a small company is resource constrained, if you like. For the past 4 and a bit years, she's been involved with our teaching team. So as an associate lecturer, she's responsible for the data analytics branch together with other colleagues that you've seen earlier in this week. The focus of Ariadni's talk will be on the use of specific platforms and tools such as the Tableau data analytics. Sorry, just give me. And so she's going to be focusing on Tableau, how you can use this technology in order to produce dashboards. And she's going to give you an extensive range of topics. She's going to cover an extensive range of topics. I hope the focus of this talk will be twofold. On one hand, you can actually see what is involved in teaching such a technology to the students, but also how this technology has actually changed the way people work in the field of data analytics and visualization. And it has certainly changed our BIS programs because our students get now a far more modern set of skills and they become even more attractive, and the market has actually been extended because of the use of such tools. So Ariadni, the floor is yours. If you want, you can share your screen. I mean, we cannot see you at the moment. We just see a black screen. So please feel free to start. Thank you.
Okay, I hope that you can see my screen now.
We see the screen, but we don't see you.
Okay.
Now we see you as well. Okay, good.
Okay, so my name is Ariadni, as George said before, and we will talk about learning analytics and visualizations. Okay, so sorry, but is it okay if I remove the camera? It's much better for me. Okay, so the training briefly will describe the aspects of the Tableau platform and how visual analytics can be used. Emphasis will be given on sharing good practice of how learning analytics are used, how we can produce dashboards representing emerging patterns of behavior and activity. I don't know what is happening in this one. Okay, so our agenda for today will include the need for visual analytics. We will explain why we came up to the need in order to create visual analytics and analyze our data. We will talk about how we use Tableau, and I'm going to give you some examples of the Tableau visualizations that we have created based on our learning analytics. Okay, let's start our talk with pictures. In the digital era that we live, it is more than important to move from papers to digital mode, not only for the environment protection, but also for saving space and make our lives easier when it comes to queries. But what is happening? Moving from paper to digital mode is leading. Why is this moving? Is leading to the drowning in data effect since very often. The raw data and the huge amount of information that we have is becoming too much. So the speed and the amount of data that is traveling around the world is making our lives quite busy. And of course, social media that are numerous are having an important role in that. Social media is not the only data source that we have. In digital era, and numerous of major data sources are leading us to what we call big data. We have archive data, we have internet documents, we have social media data, we have sensor data, public web sources, multimedia files. We have all kinds of different data sources that they become very, very big, and we end up having what we call big data. But there is there any light at the end of this huge data tunnel? Trying to find out this light at the end of this tunnel, another question is coming up. Do we really know how to handle this amount of data? Is it so easy to be done? Well, data is everywhere, and we try to collect every single piece of it without losing a bit. So any data collection is giving another thorn in our digital lives. This thorn is storage. We cannot afford to lose the data that was collected. We had to put so much effort for this, so we cannot afford to lose it. So huge physical storages were created, but again, they were not sufficient. They were not enough. So what happened? Cloud storage came into the front scene. And by believing that almost all problems with digitalization, data collection, and data storage were solved, we need to find out what we will do with our data. We need to create information from it. So we need to analyze it in order to create something meaningful, because data always have a story to tell. But what is data analysis? It is a process that models the data leading to useful information that helps the decision making. It has multiple aspects and approaches, including different techniques. For example, data mining, which is a statistical analysis technique for predictive purposes, while business intelligence focuses on business information that heavily relies on aggregation. But what is prior to the data analysis? That is another question. We have the ETL process. ETL stands for extract, transform, and loading, and is a process of transferring data between different locations. In computing, ETL is the general procedure of copying data from one or more sources into a destination system, which represents the data differently from the sources or in a different context than the sources. A properly designed ETL system extracts data from the source systems, enforces data quality and consistency standards, customs data so that separate sources can be used together, and finally, delivers data in a presentation-ready format. Since the data extraction takes time, it is common to execute the three phases in pipeline. While the data, what does it mean? That while the data is being extracted, another transformation process executes while processing the data already received and prepares it for loading while the data loading begins without waiting for the completion of the process phases. A little bit of history, ETL process became very, very popular in 70s when data warehousing was growing and was becoming very popular as well. And of course, we don't really have to forget that ETL process is a step that is absolutely necessary and is preparing data for analysis and visualizations. Nowadays, ETL process also is preparing our data for analysis and visualization through the final step that was added, that we call it analytics. Something very important for our data, and especially for the transformation phase of the ETL process, is data cleaning. Data cleaning or data cleansing is a process of detecting and correcting or removing, it depends, corrupt or inaccurate records from a record set or a table or a database, and refers to identify incomplete, incorrect, inaccurate, or irrelevant parts of the data, and then replacing, modifying, or deleting the dirty data, what we call dirty data. Can you please mute yourself?
Ariadni, if you'll make me a co-host, I will be able to mute people, please. Thank you.
Okay. Data cleansing may be performed interactively with data wrangling tools, or as a batch processing through scripting, what we call manual ETL process. After cleansing, the data set should be consistent with other similar data sets and finally be stored in our in our data source, the final data source. The inconsistencies that they were detected or removed may have been originally caused by user entity errors, so it's the most common thing, or by corruption in transmission, or by corruption in storage, or by any different data dictionary definitions or similar entities in different stores. Now, data cleaning, what I want you to have in mind is that data cleaning differs from data validation. The very basic data cleaning checklist actually has these 6 categories. Check if the data is up to date. We have to check for duplications, for recurring unique identifiers, where some people hold more than one positions in a system, and this system often creates separate records for these positions. So we end up having multiple records in a single database only for one entity. And depending on the situation, these records may be condensed. We need to check for data IDs, data labels across multiple fields, and merge data sets if all the data matches. We need to count for missing values. And when missing values are over represented in specific parts of the organization, they may screw our results. So in addition, an analysis with too many missing values, like insufficient data, runs the risk of becoming inaccurate. And we have to check for numerical outliers and calculate the descriptive statistics and the values of the quantities. And finally, we have to define valid data output and remove all invalid data values. This step is really useful for all data because character data is clearly defined. And for example, we have to define the gender. And we have to do it for, we have to use the same format for all our different data from our different data sources. Let's say that we defined the gender as M for male or F for female. These are the valid data values that we want to use. Any other values are presumed to be invalid. So this data can be easily flagged for inspection and find out what is happening there and change it in order to have common format for all our data. Now, data visualization. Data visualization is the presentation of data in a pictorial or graphical format. It enables decision makers to see analytics presented visually and grasp difficult concepts or identify new patterns. This is the most important thing for data visualizations. With interactive visualization, we can take the concept a step further by using technology to drill down into charts and graphs for more detail, interactively changing what data you see and how it is processed. Why data visualization is important? Because of the way the human brain processes information. Using charts or graphs to visualize large amount of complex data is easier than poring over spreadsheets or reports. Data visualization is a quick, easy way to convey concepts in a universal manner, and you can experiment with different scenarios by making slight adjustments. What else we can do with data visualization? We can identify areas that need attention or improvement. We can clarify which factors influence learner behavior. For example, we can help understand which learning activities to place where. And of course, we can predict learning activity and behavioral patterns. So these are all the reasons why data visualization became so important. Now, why we use Tableau? Tableau is a very effective tool to create interactive data and visualizations very quickly. It is very simple and very user-friendly. And with Tableau, you can create complex graphs, giving a similar feel as the pivot table graphs in Excel. Moreover, you can handle a lot of more data and quickly provide calculations on data sets. Users can create visualizations quickly and switch between types easily in order to find the model that best represents the message they want to pass through the visualizations. And it is extremely easy to integrate with multiple data sources, and the user interface is very well organized. Something very important as well is the last but not least, the reason that we use Tableau is that we can create visualizations for a large amount of data without crashing. Introduction to Tableau. Okay, guys, data analytics is a new term for many people. So data analytics refers to qualitative and quantitative techniques and processes used to enhance productivity and business gain. So data is extracted, is acknowledged, and divided to identify and analyze behavioral data, techniques, and patterns. The idea is to make sense of the data we have, to analyze it and share better business prospects. And how are we going to do it? With the concepts of analytics. So modeling and visualizing is one of the major aspects of analytics, and Tableau, of course. And so to get an upgear for this, you can really need to understand your data as a whole. So let's have a look at the tool and find out all the functionalities that it's giving us in order to be able to create, not only as a teacher, also as a researcher, but also as a professional, our visualizations. Tableau's homepage is divided into three main areas. We have the connect, the open, and the discover. Now, connect your data. We have three different parts there. Under to a file, we can connect to data stored in Microsoft Excel files, for example, text files, access files, Tableau extract files, statistical files such as SPSS files and R. And with more, we can identify with our Explorer the location of the file that we want to actually load into our Tableau. Now, under to a server, we can connect to data stored in databases like MySQL, Microsoft SQL Server, or Oracle. There is a huge variety of different servers that we can connect, and we're going to see that in more details. The server names listed in this section change based on which servers you connect to and how often. So the list that you can see here, it depends on how often you use a very specific server. Now, open section gives you the most recently used workbooks or the workbooks that you want to bin. And at the bottom, we have some sample saved data sources that you can use in order to explore Tableau functionality and get some ideas. And finally, the discover and explore content produced by Tableau community provides training videos and tutorials. Now, server connection, as we said before, offers a variety of servers or database servers that is becoming quite difficult not to be able to create your connection. Now, even if you're not lucky enough to identify your server into this list, Tableau is giving you the option to create your own JDBC or ODBC connection. Just a tip here for Tableau is that in order to be able to connect to your server, either your application server or your database server, you have to make sure that you have the drivers. For some servers, especially for some database servers, Tableau has already embedded the drivers that you need, but for some others, you may have to download the drivers in order to be able to connect. Tableau, by the time that we will load our data and we will be ready to work with them, Tableau is using the database join types when more than one data sets are imported. So by default, Tableau applies inner join in order to, and is trying to identify same column names. So this is what we need to have in mind. But both join types and columns can be changed accordingly. This means that I may use my own columns and my own join type in order to create my own different data set. And of course, Tableau is using SQL join types in order to produce the different data sets. We have the inner join, left join, right join, and full outer join, very common. And the logic behind them is exactly the same as we have for databases. Now, by connecting the data, Tableau identifies and assigns each field in the data source to either the dimension area or the measures area of the data pane, depending on the type of data that the field contains. And what we do with that, we use the dimensions and measures accordingly in order to build our visualizations. But let's see what dimensions and what measures are. Well, dimensions contain qualitative values, such as names, dates, or geographical data. Dates, of course, can be used both as dimensions and measures. It's a special category of data, but Tableau is identifying dates as dimensions first. Dimensions are used to categorize, to segment and reveal the details in our data, and they affect the level of detail in the view. And measures contain numeric, they contain the quantitative values that we can measure. Measures, what is happening with measures? They can be aggregated. So by dragging a measure into our view, Tableau by default applies an aggregation to that measure. And that aggregation that Tableau applies by default is the summary aggregation. Now, what you need to have in mind is that dimensions gives the headers to our visualizations, while the measures gives the rows to our visualizations. Now, Tableau represents data differently in the view depending on whether the field is discrete, what we call blue, or continuous, what we call green. You will often hear Tableau developers to talk about the blues and the greens. Continuous and discrete are mathematical terms and means that forming an unbreak whole without interruption for continuous, and discrete means individually separate and distinct. Let's have a look to this example so we can understand how this affects differently our visualizations. Because the quantity field is set to continuous, it creates a horizontal axis along the bottom of the view. In the second example, the quantity field has been set to discrete. As far as you can see, the quantity became blue. With Tableau, we can change our data if we want to add a measurement to a dimension in order to be able to create different visualizations. We are allowed to do that, but we have to be very careful. Now, quantity became a discrete. So now it creates horizontal headers instead of an axis, because it's not continuous anymore. In both examples, you see that the summary of sales, which is the default aggregation that Tableau applies on measurements, is untouched. So what is happening here? We have quantity and summary in continuous. So we have an axis as a visualization, but changing the quantity to a discrete value, we can see that we have what we call the bar chart. So it creates a vertical axis because it continues and it's been added to the row shelf. Now, something very important that we do with our data is we put filters. Filtering is an essential part of data analysis. So filtering data means to set conditions so that only certain data is displayed. It is done to make it easier to focus on specific information in a very large data set or in a very big table of data. It does not remove any data, or it does not modify any data. It simply changes which rows or columns appear. In other words, it is creating a different data set. Now, filtering is really important, and we can find filters everywhere. For example, we can find filters in an Excel file. Of course, we can find filters in a very popular platform that is called CRM. Filters in Alteryx. Alteryx is a tool that Tableau is using for the ETL process, along with Tableau Prep. If you don't want to do the ETL process manually, then you can use either Tableau Prep or Alteryx in order to be able to work on your ETL process. The difference is that by the time that you will have the activation of Tableau, automatically you have the activation of Tableau Prep. For Alteryx, you have to apply for another activation key. So probably the course is going to be different. Of course, as far as you can understand, we have Microsoft Access database, and of course we have filtering there as well. My favorite one, Oracle. So this is a filtering data in Oracle. This is a filter dialog box. And of course, filtering data in Tableau. Filtering is an essential part of analyzing our data. And the question is why? The reason is because with filtering, we can set conditions so that only certain data is displayed. It is done to make it easier to focus on specific information when we have a huge data set, when we have a huge amount of data, or in a big table of data. So filtering does not remove or modify any data, as we said before. It simply changes what we can see. Now, there are many ways that you can filter your data from your views. And you may display interactive filters in the view, and you may format filters in the view. And of course, filtering is a very nice way so we can make our visualizations more interactive. Tableau performs a number of filters on the view in a very specific order. This is called the order of operations, and filters are executed in the following order. We have the extract filters, we have the data source filters, we have the context filters, and we have filters on the two basic categories of our data, on dimensions and on measures. On dimensions, whether on filter self or in the filter cards in the view, and same with measures. We may apply a measure in the filter self or in the filter card in the view. Let's start with extract filters. Extract filters are saved subsets of data that are used to improve the performance of our visualizations or to take advantage of Tableau functionality that is not available or supported in the original data. After we do the data extraction, the total amount of data can be reduced by using different filters and configuring other limits. Now, extract filters are the creation of an extract that can be refreshed from the original data source. And by refreshing the data, we have two options. Either do a full refresh that replaces all of the contents in the extract, or an incremental refresh, which only adds rows that are new since the previous refresh. This is what we call, while we're doing the ETL process, because this is part of the ETL process, what we call the deltas. And we may have, according to the amount of data that we have, we call it either daily delta, a procedure that we do daily, or weekly data. Depends on how often the organization will decide that wants to do the refreshing of the data. The extract filters can be applied after you connect your data and set up the data source on the data source page. In the upper right corner, what you need to do is you have to select the extract and then click the edit link to open the extract data dialog box. By default, the connection is live, but when we want to avoid to run data analytics and Tableau to have access in our database, in our data source live, we may use an extract. Now, in the dialog box, what you may do, you may decide how the extract data should be stored. You may determine how much data to extract. You aggregate the data in the extract, you select the number of rows you want to extract, and you apply any limitation that you want to create for the extracted data set that you want to work on it. Sorry. Second category of filtering is data filtering. So when you publish, data source filters are created on the data source in order to reduce the amount of data in the data source at the very beginning. So they are really useful for restricted the data that users can see. And when you publish a workbook or a data source, it is also very useful when you publish a data visualization to define access permissions to external users for downloading or modifying your data source and at the end your data visualizations. So this is when you publish, especially when you use a Tableau server and you want to publish a visualization, this is very good in order to, let's say, restrict the access or cut the access to any other user than the owner of the visualization and the data set. How can I create my data source filters? In the primary method to create the data source filter is to add filters in the section in the upper right corner of the page. So we have the dialog box of the edit data source filters, and we can add as many filters and as many limitations that we want. And after that, we can click OK, and we can have our data source filtering. Data filtering has also the context filters. Context filters, they are used in order to improve performance. So when we have a lot of filters, or we have a lot of, or we have a large data source, a huge amount of data, the queries can be very slow. So this means that the visualizations can be very slow. And when we're talking about visualization, we're talking about the interactions of the visualizations. So you can set one or more context filters to improve performance. Another thing that we can do with context filters is we can create a dependent numerical or top-n filter. So you can set a context filter to include only the data of interest and then set a numerical or a top-n filter. For example, suppose you are in charge of breakfast products for a large grocery chain. Your task is to find the top 10 breakfast products by profitability for all stores. Now, if the data source is very large, you can set a context filter to include only breakfast products. We have a category on our products, which is called breakfast, and we choose only this category. Then you can create a top-n filter by profit as a dependent filter, which would process only the data that passes through this context filter, the top 10. Let's see an example of how we can create a context filter. In this example, we have the SIP mode dimension, which is set to be the context filter for the view. So the region filter that is below the SIP mode is computed using only the data that passes through the SIP mode that we have added as a context filter. So in other words, what we are doing with context filters, it's a way to create a smaller data set and be able to focus only to this data for our visualizations. Filters on dimensions. As we said, dimensions contain discrete categorical data. So filtering this type of data generally involves selecting the values that you want to include or exclude. How we do that? We drag a dimension from the data pane to the filter self. And after we do that, the following filter dialog box appears. What is important here is that each tab adds additional definitions to your filter. For example, you can select to exclude values under the general tab. You can also add limits under the top tab. Remember that we said that we can create a top-n filter. We can add some wildcards or different conditions. And it also gives us the opportunity to add our piece of coding there and create our own filtering. Of course, as we can do with dimensions, we can do with measures. We can add measures at the filtering pane, and measures that contain quantitative data. The filtering type generally involves selecting a range of values that you want to include to your visualization. So we take the sales measure from the data pane that we have, and we put it on filters. We just drag and drop it, simple as that. Same technique in order to create, to add a dimension to our filter pane. And after we drag and drop a measurement into the filter pane, the following dialog box will appear. And notice that this filter dialog box differs, first of all, from the dimensions dialog box, but of course differs depending on whether you are filtering categorical or quantitative data. It's also different when you want to filter date fields. It's something that we will see later. Select how you want to aggregate the field. We have a range of different aggregations. It's summary, it's average, median, count, distinct. We have the minimum, the maximum. We have standard deviation, we have variance. And after that, we can click the next. This will lead us to the following dialog box, where in the subsequent dialog box that you see here, we are giving the option to create 4 types of quantitative filters. We have the range of values that we can do it manually if we want. And we can choose if we want to show only relevant values. And of course, if we want to include null values, because what is happening with Tableau is by default, null values are ignored from our visualizations. We have the at least, where we can choose the minimum value that we want to choose, at most, and special. With specials, we have the chance to create our own piece of code with filter when we create filters for measures. And we have some additional filtering that has to do with dates. Dates are a special category, not only for Tableau, but for databases as well, because it can be used either as quantitative or qualitative piece of information. So when you drag a date from the date pane to the filters itself in Tableau, we're going to have this field dialog box. As far as you can understand, we can have it, you have both colors, you have both blues and greens. What does it mean? It means that I can actually, I can treat my date either as numeric value or as a header value. I can add columns, I can add rows into my visualization, depending on how I'm going to choose to use my date field. We will continue with how we create filters with keep or exclude data into our view after our break. Let me stop sharing, and I can pause the recording for your break. We will continue with data filtering. We have already talked about the different types of filters that we use on Tableau in order to create different data sets, and of course, to make our visualizations more interactive. Another option that we have when we are talking about filters is to keep or exclude data from our views. This means that we can filter individual data points, what we call in Tableau marks, or a selection of data points from our views. To filter marks from the view, what we need to do is to select a single mark to have it as a data point, or click and drag in the view to select several marks. Let's see this animation in order to find out how we do that. After we choose the marks that we want to keep, we select the keep only option to keep only the selected marks in the view. And as far as you can understand, our view is becoming bigger because we are focusing only to the selected mark. Same for exclude as well. When we want to exclude some piece of information from our visualization, what we do, we select the marks that we want to exclude. After that, from the dialog box that appears, we select exclude in order to remove the selected marks from the view. Let me clarify something here. I'm excluding and removing these marks only from the view, not from our data set. So the data set remains untouched. Another thing that we can do with filters is that we can apply the filter that we have created in a very specific worksheet to multiple worksheets. So when we add the filter to a worksheet, by default, it applies only to the current worksheet. But there are times that we want this filter to be applied to other worksheets in the workbook that we are working on. So we can select specific worksheets to apply the filter, or to apply it globally to all our worksheets that use the same data source or related data source. So this means that we don't really have to create the same filter again and again and again. We can create it once, and we can apply it to the entire workbook or to specific worksheets. Now let's continue with another very interesting topic that has to do how we sort our data. Data sorting is a process that involves arranging our data into some meaningful order in order to make it easier to understand, analyze, or visualize them. When working with research data, sorting is a very common method that is used for visualizing data in a form that makes it easier to comprehend the story that the data is telling us. So even how we sort our data is important when it comes to the final result of our visualizations. So why data sorting is important? We just explained that. We need to arrange our data in some meaningful order so we can make it easier for us to understand them. And of course, to be able to make it easier to comprehend the story that the data is telling us. There are many ways to sort data in Tableau. When viewing a visualization, data can be sorted using simple click options from an axis, from a header, or a field label. In the authoring environment, additional sorting options include sorting manually in headers and legends, and using the toolbar sort icons, or sorting from the sort menu. So a nested sort considers can be applied and considers each pane independently and sorts the rows per pane. So we have different options that we can sort our data. Let's see them all one by one. What we do first, we may sort our data from an axis. In this example, we have three different axes. We have the hue, we have the color, and we have the metrics. So what we do, we hover over a numerical axis to bring up the sort icon. As far as you can see, it's highlighted. And then we click the icon that we want to sort. In this example, the sort is applied to color, sorting the rows based on the values for metric A. So in this example, we are sorting using the colors, but we are based on a metric. Another way that we can sort our data is choosing specific fields in the visualization. So if we can use the sort icon, and we can choose if we want to use which metric we want to use. Now, have in mind that if the sort icon does not appear, this means that the functionality may have been turned off, or it might not be possible to sort the view using a specific metric. So all the options, all the possible options that we can have on Tableau, let's say by itself automatically removes or gives us all these different options that are possible for that specific visualization. Now, what we have here, we have a very nice example to find out how we can sort our data using the toolbar. Have in mind that in this example, what is happening? If we do not select a field before we do the sorting, the default behavior is of Tableau is to sort the deepest dimension. In this example, the sort is applied to hue because hue is the deepest dimension. First dimension is the material. Hue is the second and last dimension, so by default becomes the deepest dimension in our visualization. So unless we choose the material field prior to sorting, we will be able to have to sort our data using the material first, and after that using the hue dimension, which is the deepest. And of course, by removing hue from our visualization, we have a different result there, and we have a different type of sorters there. Now, another way that we can sort our data is using headers or legends. How we do that? First of all, we have to hover over a header to bring up the sort icon. Then we have to click the icon to sort. And in this example, the sort is applied to material, sorting the order of the columns, paint, fabric, and paper based on the values for green, since the header was used for the sort. So we, as far as you can see, we have the header green that was used. And after that, we sort our visualization according to the material. And for the green one only, we have the paint and the fabric and the paper sorted differently. Another way that we can sort our data is by drag and drop. This is a manually way to sort our data, and we select a header in the visualization or a legend, and we drag it to the correct location. When we are ready to do that, you can see that a heavy black line indicates where this legend will go. This is very useful when you want to sort your data in a very, very specific way, and there's no other way that you can do it. Now let's talk about the nested. Nested sort considers each pane independently and sorts the rows per pane. In this example, purple is sorted above green for fabric and paper, but below green for paint. Have in mind that sorting from an axis gives a nested sort by default, while the non-nested sort considers the value across the panes and will have the same order of values per pane. So in this example, purple is above green for all the materials because in aggregate, purple is higher than green. And sorting from a field label gives a non-nested sort by default. So this is the difference between the nested and the non-nested sort, and it depends on how we want to present our data again and how we want to choose to give the bigger options. Another thing that we can do with Tableau is to group our data. Grouping is used for a combination of related members in one field, correcting data errors in case that something that was, we missed something during the ETL process, and to answer what if type questions. What do we mean by combining related members in a field? I mean that we can have the option of English or history, and we want to create a major group that we will call it liberal arts, or we may have biology and physics and create a group of science. We also said that groups are useful for correcting data errors. So most probably for cases that something was missed from the ETL process and we don't want to go back and do it again. In this case, what we can do, we can create groups that will actually gives us these fields into a very specific format. I'm having two examples here. Let's say, for example, that we want to have the state California in a very simple one format. So in our data set, we may miss the fact that we have the California state written differently, like California, the whole word, just a part of the word, like Calif, or we have the CA, which is the state code, but we want to keep only the code of the state. So in that case, we will create a group with all these three different values, and we will say that all of them will be referred from now on as CA. Same for, let's say, for the module code, CST 3340. We can say that we can correct the different type of information into one data point, which is going to be CST 3340 with capital letters, no spaces, no dashes, not anything. Another reason that we're using the data group is to answer what if type questions. For example, what if we combined the East and the West regions? Or what if we compare the Europe continent against the African continent for many, many reasons? for sales, for touristic reasons, for anything. We are trying to create groups there in order to be able to have, let's say, a bigger view of our data. Now, how to create a group? There are various ways that we can create a group, and we can create it from a field in the data pane, or by selecting data in the view and then clicking the group icon. By selecting data in the view, what we can do, we can select one or more data points. And then on the tooltip that appears, we can click the group icon. Note that you can also select the group icon on the toolbar at the top of the workspace. Now, if there are multiple levels of detail in the view, you must select a level to group the members, and you can select to group or all dimensions or just one dimension. This is an example of how we can do the grouping and choosing all subcategories than fonts. After that, we will click the group icon and we will create our group. Now, how we group our data from the data pane? What we do is that in the data pane, we right-click a field and then we select Create Group. This is how we do it. Right-click on Dimension subcategory, and after that, create a group. Now, in the Create Group dialog box, we can select several members that we want to group, and then we click Group. We may also include others, and we may rename our group and give it a very specific name. Now, the selected members that are combined into a single group, in this example, is the bookcases and tables. This is, let's say, the default name that Tableau will apply, depending on the subcategories that they were chosen for our group. Now, a default name, the default name can be renamed. And how we can do that? If we select in the list, and after that, we click Rename. Now, include another group. When you create groups in Tableau, you have the option to group all remaining or non-grouped members in another group. This is highlighting certain groups and comparing specific groups against everything else could be applied. Let's see this example. If we have a view that shows sales versus profit product category, you might want to highlight the high and low performing categories in the view and group all other categories into another group. So how are you going to do it? By applying include other, that we have it at the end, this checkbox here, when you are creating your group. Now, if we do not include the others, if we do not want to group everything else into the others group, we can see here from this example that shows sales versus profit product category, And we might want to highlight the higher and low performing categories in the view and group everything and leave everything else as is. Now, another thing that we can create with our data in Tableau is we can create different data sets. Sets are used to compare and ask questions about a subset of data. So sets are custom fields that define a subset of data based on some conditions. And we have two different types of sets. We have the dynamic sets and the interactive sets. The members of a dynamic set change when the underlying data changes. So dynamic sets can only be based on a single dimension. To create a dynamic set in the data pane, you go under dimensions, right-click a field, and after that you select create set. Is same way that we use the group. Now, in the create set dialog box, what we can do, we have different options that we can configure our set. You can configure your set using the following tabs on the dialog box: general, condition, and top. And the general tab use to select one or more values that will be considered when computing the set. You have also the option to include everything, to exclude everything, to include, to select and to check or uncheck everything. And you have the option to exclude information from your set. Now, the condition tab is used to define the rules that determine what members to include in a set. Now, in this example, you may specify a condition that is based on total sales that only includes products with sales over 100,000. Now, the top tab is used to define limits on what members to include in the set. And in this example, you might specify a limit that is based on total sales that only includes the top 10 products based on the sales. And in this case, because we are using a measurement, we have to apply the aggregation as well. By default, we said that Tableau applies the aggregation summary, but we have the option to change that. Now, when finished and we click OK, the new set is added to the bottom of our data pane under the set section. A set icon indicates the field that is a set, but have in mind that groups will not be in a separate, let's say, space in our data pane. It will remain under dimensions, because a dimension was used in order to group specific data. Another thing that we can do is we can create a fixed set. So the members of a fixed set do not change. And the fixed set can be based on a single dimension or multiple dimensions. Now, in this visualization, we select one or more marks or headers in the view. We right-click the marks, and we select Create Set. After that, we can name our set as we want, and we can click OK, so the set can be created. This is another way that we can create our set from our visualization. In the Create Set dialog box now, we can type a name, as we said, that we can name our set as we want. And optionally, we can complete any of the followings. The option to exclude these members, to remove any members that you do not want to separate members by enter a character of your choice, add to filter self to automatically move the sets to the filter self when it is created. So I can put it automatically there, and I don't really have to do an extra, let's say, job to drag and drop it into the filter self myself. Now, another option that set has is the show in and out members. In most cases, when you drag a set to the visualization, the set will be displayed using the in-out mode. This mode separates the set into two categories. In is the members that exist in the set, and out is any members that are not part of the set. Now, showing the members in the set automatically adds a filter to the view that includes only the members of the set. In Tableau, in order to do that, we right-click the set in the visualization workspace and select the show in and out of set, or we show members in the set. Another thing that we can do with sets is we can combine them. So you can combine two sets to compare the members. You can combine sets you create in order to create a new set, and you can do that. You can do it because you want to create a combination of all members, just the members that exist in both, or to create a set with members that exist in one set, but not the other. How we do that? For example, in order to create a combined set in the data pane, we select both sets. In this example, we have customers 2016 and customers 2017. By holding the Control key and right-click the selection and then select Create Combined Set. Now, this example uses sales data to determine how many customers who purchased in 2016 also purchased in 2017. For example, you may wonder how many customers that purchased last year also purchased this year. And when we're talking about last year, we're talking about 2016. And when we're talking about the current year, we're talking about 2017. Or if a customer purchased a specific product, what other products did they buy? You can answer these type of questions using the create multiple sets and combine them. And as far as you can understand, as far as you can see, we have different join options and sets, in order to be combined, they use the SQL basic join types, the full outer join, inner join, left or right join. And another option that we have is we can define how we can separate the members by typing the separator that we wish. In this case, we have chosen the comma separator. Now, what is the difference between the groups and the sets? Usually, the case between groups and sets get mixed up in people's head. Why is this? Because of course, this is totally normal, as they look so similar. They both combine the selected units and create a new set or group of data, but they have differences. Let's discuss the basic differences between groups and sets. Sets are more complex, but they offer greater flexibility. Groups many times will do the job if the flexibility offered by the set is not really necessary, and it will give us the result that we want. A great advantage of sets is that the data within can be exported very easily and used from the business, while with groups we do not have this advantage. Another thing that we can do with sets is to choose how we will present our sets, with an in and out option or the show members in set option, where in groups, the only thing that we can do is to group or ungroup our data. Now, sets are extremely useful when we have to compare one group of things against another because of the flexibility. For example, a dimension member can only belong to a single category in a group, but using sets, that same dimension value could exist in many other sets, like let's say that we have the value cat, and we can include cat in mammals, in furry things, in pets set. So we have this flexibility against group that it can belong only to one group. Now, sets can be referenced directly in a calculation. And since they imply a filter, they can be quite useful in a hierarchy. We said that we can add, by the time that we will create our set, we can add it automatically to the filter pane. And for example, we might drop a set into a hierarchy, so that when someone opens that level of the hierarchy up, the levels are pre-filtered by what the set does. Now, something else that is very, very useful and we can create using Tableau is to create parameters. Of course, parameters are not used only in Tableau, but we have this option here as well. Now, what parameters are? Parameters are dynamic values that can replace constant values in calculations, in filters, and in reference lines, because we use quite often reference lines in our visualizations. And parameters can be more dynamic and interactive by using them in the parameter actions. Rather than manually editing the calculation and all dependent calculation, we can use a parameter. Then, when you want to change the value you open the parameter control, you change the value there, and all the calculations that use that parameter are updated. How we create a parameter? In the data pane, what we can do, we can click the drop-down arrow in the upper right corner and select Create Parameter. In the Create Parameter dialog box, we give the field a name. We write a comment in order to describe the parameter. Of course, this is optional. It is only for you to remember what this parameter is and why it is used. And we can specify the data type for the values it will accept. Specify a current value. This is the default value for the parameter. We need to specify the display format to use in the parameter control. And finally, we need to specify how the parameter will accept values. Allowable values is the availability of those options is determined by the data type. So as far as you can see, we have a lot of different parameters in order to be able to create a parameter. The parameter, by the time it will be created, is listed in the parameter sections at the bottom of the data pane, and it's going to be under the sets. Now, let's see an example in order to find out how parameters are used. In this example, the parameter control is used to modify the filter that shows the top 10 products. So in that case, we can say that we can have the top 10 products, 15, 20 top products, and so on. So to show the parameter control, what we have to do is to right-click the parameter in the data pane and select Show Parameter Control. Another example using a parameter is in this visualization, which is a world map, and we created the parameter set birth rate. On the map shows low birth rate countries in one color, which is the orange, and high birth rate countries in another color, which is the blue. You can raise or lower this parameter value incrementally in order to see how changing the definition of high birth rate and affects the map. And you can do it using the bar. Now let's continue with the most important thing that we can do with Tableau, and the last topic for this training session, the calculations. A calculated field is a field that derives its value by performing a function on values from other table fields. So calculated fields allow you to create new data from data that already exists in your data source. There are cases that your data may not include all the information that you need in order to answer your questions and create your visualizations. In this case, we may produce that information with calculations. Of course, when we have calculated fields, it's not only on Tableau. We have it on databases as well. For example, in Oracle, it is called a visual column, and is a table column whose values are calculated automatically when other column values or another deterministic function, or another determination expression is applied. And when we are talking about deterministic function, it means that it always returns the same result set when it is called with the same set of input parameters. Where else do we have calculations? Something very simple. We have it in Excel. that we can call them calculated columns, and there we can enter the different formulas. So it's not something new, but calculations are really useful when we want to create new information from our existing raw data. Now, when a calculated field is created, we have a new field, or you may call it column, in the data source, and it is stored there, and the values or members of which are determined by a calculation that you may control. Now, this new calculated field is saved to the data source in Tableau and can be used in order to create more robust visualizations. Have in mind that the original data, the raw data, they were used in order to create this calculation column remains untouched in case of calculations, and the values, the original values, do not change. When a calculated field is created, as we said, a new field or column in the data source is created, the values or members of which are determined by a calculation that you may control. So this new calculated field is saved in the data source in Tableau and can be used in order to create, as we said, more robust visualizations. The reason that what we can create with calculations, we use calculations in order to segment our data, to convert data types, such as converting a string to a date and vice versa, in order to create aggregations, to filter results, or to create ratios. The type of calculations that we have is the basic calculations that allow you to transform values or members of the data source level of detail or at the visualization level of detail. This means a row level calculation or an aggregation level calculation. We can create table calculations that allow you to transform values at the level of detail of the visualization only. And we can create the level of detail expressions that allows to compute values at the data source level and the visualization level. Like the basic calculations, however, level of detail calculations give more control on the level of granularity. Now, basic calculations allow you to transform values or members at the data source level of detail or at the visualization level of detail. Let's see how we can create a basic calculation. In order to see a list of available functions, what we have to do, we have to click the triangle icon on the right side of the calculation editor. And after that, in function includes the syntax, includes a description, and an example for your reference. The way that I can create calculations in Tableau, as far as you can understand, we have a lot of similar functions like Excel. Tableau is written in C++. So when you want to create more complex calculations, the logic that you use for your calculation is based on object-oriented programming. So if you have knowledge from C++ or Java, it will not cause you any problems in order to create a calculation. This is an example of a basic calculation, something pretty simple, but also at the same time very useful. Why? Because we do not have the cost of our product, but we can create it from the sales and the profit columns. This is another example of a basic calculation. Another thing that we managed to create is the profit. So, of course, you have to realize that by the time that even the calculation is used in the columns or row shelf, Tableau applies by default the aggregation summary. So it's something that you may change because it's not always very useful to have a summary. We may choose average, we may choose count, we may choose minimum, maximum. It depends on how we want to present our information. And of course, this applies for the calculation fields as well. Let's see another example. So if you have a sales and profit field in your data source, but you want to calculate cost, how you can do it? You can create a cost field using a formula similar to the following example. So we can click directly on the column shelf, and we can say that I want to have the sales minus profit. I will apply this calculation, and by the time that we'll do it, I will drag and drop it into the measurements data pane, and I will rename it as cost. Table calculations. Table calculations allows you to transform values at the level of detail of the visualization only. And table calculations are a special type of calculated field that computes on the local data in Tableau. They are calculated based on what is currently in the visualization and do not consider any measures or dimensions that are filtered out of the visualization. Table calculations are used for a variety of purposes, including transforming values to rankings, transforming values in order to show running totals, in order to show percent of total, and in order to do addressing and partitioning. How we can apply table calculations? Right-click on, for example, on the summary of sales that we have in our table, in our visualization, and after that, we will choose Add Table Calculation. In this example, we have the following table, which has the summary of sales for the years. And we have the categories in rows. We have the categories of quarter and month. In what we do, the calculation is computed across the columns, the year and the order date for every row that is in the month order date. Now, in this example, in the following table, the calculation is computed across the columns, year order date, for every row that we have the month and the order date. This is how we do it. Let's see it one more time so you can have a clear view of what is happening. Now let's see the difference between the basic calculations and the table calculations. Table calculations and calculated fields are similar in the sense that they both use functions to compute the results. Now, the difference is how and where the computing takes place, where the result is saved, and if it can be reused in more worksheets. Table calculations are more simple, and their scope is more limited compared to calculated fields. Calculated fields are much more diverse, enabling deeper analysis. Okay, let's see the level of detail expressions. For us, we have another category of calculations. Level of detail calculations allows to compute values at the data source level and the visualization level. They are like basic calculations. However, level of detail calculations give more control on the level of granularity. Level of detail expressions can perform at a more granular level where we have the include, a less granular level that we can exclude, or an entirely independent level that we have the fixed, with respect to the granularity of the visualization always. Let's see them one by one. Include level of detail expressions, compute level values using the specified dimension in addition to whatever dimensions are in the view. And include can be useful when you want to calculate at a fine level of detail in the database and then reaggregate and show at a coarser level of detail in your view. In this example, the include level of detail expression calculates a summary of sales on a per state basis. So we include the state, and after that, we add the summary of sales. Include, in this case, has one dimensional parameter, and that is the state. So we aggregate by the dimension state, which is not in the view. Let's see that. The calculation is placed on the row shelf and is aggregated as an average. So the resulting visualization averages the summary of sales by state across the categories in the comparison with the summary of sales that we have below. So as far as you can see, the result is different, and we can actually create visualizations that will be very helpful when we want to compare stuff. Now, the exclude level of detail expressions declare dimensions that we want to ignore from the view level of detail. So exclude can be very useful for percent of total or difference from overall average scenarios. They are comparable to such features as totals and reference lines. Exclude cannot be used in row level expressions, where there are no dimensions that we want to ignore, but they can be used to modify either a view level calculation or anything in between. In this example, the region is excluded from the calculation of the summary of sales. Let's see how we apply in our visualization the exclude. Dropping exclude region on colors side, we have the total sales by month, but without the regional component. Now fixed, fixed level of detail expressions compute a value using the specified dimension without reference to the dimensions in the view. Fixed level of detail expressions do not consider the view level of detail, and the calculation only uses the dimension referenced in the calculation. I have to say that I'm using fixed quite often when I'm doing data analysis. It is really useful. What we have here, we have a fixed dimension, which is the region, and our calculation is based on the summary of sales. Now, in this example, the calculation uses only the dimension referenced in the calculation, which in this case is a region, because we said that we want this calculation to be fixed by region. Because of this, you can see that the values for the individual states in each region, they are identical. So we have the category, the region category central list. And as far as you can see, every state that belongs into that region has the same summary of sales. The entire level of detail expression is enclosed in curly braces, followed by the scoping keywords, which are fixed, include, and exclude, followed by a dimension declaration, which is optional, especially when we use exclude, and followed by the aggregate expression that is separated by column. So this is the level of detail expression syntax for the LOD calculations. Another thing that we can create is what we call ad hoc calculations. Ad hoc calculations are calculations that you can create and update as you work with a field on a self in the view. And let's see how we can do it. Ad hoc calculations are supported on the rows, on the columns, marks, and measure value cells. Where they are not supported on the filters or pages cells. In order to create an ad hoc calculation, what we have to do is to right-click in order to have the pop-up window, choose new calculation or we may double-click on an empty self. In this case, we did that on the row self. Or on an empty part of a self in order to create new calculation. Now, how we create an ad hoc calculation? As we said, we open a part in a self. In this case, we did that in the row self. And what we have to do is to type to create the new expression or drag new fields into the expression from the data pane or elsewhere in the view. After that, we have to press the Control and Enter in order to commit the expression and update the view without closing the calculation. Because if we close a calculation and we add it in the data pane, then it's going to be basic calculation. It's not going to be an ad hoc calculation anymore. Now, if we press Enter, Tab, or click outside the expression to commit the expression, and we close the calculation and update the view, you have to realize that the ad hoc calculations are not named and how we can separate them from the basic calculations. But what is happening is that they are saved. So we will not lose them if we change our worksheet or if we close our workbook. And if we want to save them, in order to use them in another workbook sheet, because ad hoc calculations are actually something that is created on a very specific worksheet and we cannot transfer it to another, just like we do with filters, we have to copy it into the data pane. If we do that, we will be prompted to name the calculation. And as I said before, it will not be an ad hoc calculation anymore. It's going to be a basic calculation. Now, let's talk about tips for calculations. Which calculation is right for my analysis? That is always a question. Well, it depends on the needs of your analysis and the question you need to answer. So when trying to decide which calculation is the most suitable one, what you have to do is to consider the following questions. Question number 1, do I really have all the data values that I need for my visualization? If the answer is yes, then I may use a table calculation. If the answer is no, then I have to create my value using a basic expression. This means by creating a basic visualization. Does the granularity of the question match the granularity of the visualization or the granularity of the data source? Now, if the answer in this question is yes, we use a basic expression. Now, if the answer is no to this one, what we can do is we can use a level of detail expression. Question number 3. Do I need ranking, inter-row calculations, moving calculations, or recursion? Now, in this case, if the answer is yes, then we use a basic expression. And if the answer is no, then we use a level of detail expression. Now, let's talk about tips for learning how to create calculations. I have to say from my experience that there is no easy way to know exactly how to create the perfect formula. It takes practice and research. However, there are some ways that you can start to learn. When you know your question or purpose, if you know the data, the type of data you need, this can help you choose the correct function as well as to format your formula properly. Another thing that you can do is to learn Tableau functions. There are many different functions available. Each type serves a different purpose, and Tableau gives us the description along with an example for each function that can help. Learn how to format the calculations. So once you are familiar with the different types of Tableau functions, and of course their purpose, make sure that you learn how to format calculations using the proper syntax. Because giving a different format, not only for our calculations, but for all data, is giving also a different result to our visualizations. Another thing that you can do is to learn from other examples. This is what I always do, making my research to find out if somebody else had the same problem or had the same question, just like I did, and to find examples and solutions from them and take ideas from them. And of course, another thing that you can do is what we always say, especially the developers, is the trial and error technique that we can try. And okay, if we get an error, we can retry again until we find the right and the perfect formula. Now, let's see some examples from analytics that we have created for the intelligent environments. I'm going to give you a few ideas from smart sensor data, from augmented reality data, from personalized assessment data, and from student presentation data. This is a plot of percentage of sweat recorded on seconds, broken down by the, this is model roles. And we have details that are shown for the group numbers. And we have two different categories. This sweat recordings while they are doing the Scrum meeting or they are doing the project meeting. That is another example that we have the Belbin categories, and we can see that we have the different levels of expressions that we have here. Another analysis is that when the students had their project meeting and we were using cameras in order to record their expressions, their facial expressions and their facial emotions. And they are according to the MBTI role they have. Google Glass responses by role. When it comes to Belbin, three main categories. And after that, we have the different profiles according to the Belbin category. We have the action, social, and thinking. We have student observation data per the different topics that they had to do and how they actually, this is pretty metric in order to find out how they did per topic, and of course how they were working during the months. This is the goals observation application, and we can see how groups are performing, not only for their group goals, but also for the individual goals, in order to find out which one is, let's say, the best student in the group, and which one is working less. Another example that I have here for you is observations per topic, and according to their VARC learning style, in order to find out how they act according to their VARC learning style. Visuals, orals, learn, read, write, kinesthetic, and multimodals. This is another diagram that I have created in order to give the performance according to the time that groups had for their presentations. And of course, we can understand that something is wrong with group 8, that they actually, when the maximum number for the group presentation is 10 minutes, we can find out that something went really wrong with group 8 here. And this is my email address for any questions. So I'm going to stop sharing my screen now, and I'm going to ask you if you have any questions. Any questions, anybody? No questions, just thank yous. George?
Sorry, I'm in the assessment board at the same time, Ariadni. What can I do for you?
No, actually we finished, and it doesn't seem
we
that
can
we
stop
have
the recording.
Yeah.
If you have any questions, yeah, I'll stop the recording now.